Okay, so today we're going to talk about traditional algorithms with long division, and we're going to talk about zeros in the quotient. So if you remember, if we have our, let me make it a different color. If we have our division sign here, we've got our divisor out here, our dividend in here, and our quotient as the top as our answer, right? So we're gonna have zeros in our answer. So again, we've got our DMS down dude to help us with our algorithm as a mnemonic device. So divide, then multiply, then subtract, and then bring down. However, this time we're gonna run into some times when our divisor is not gonna go into the number, and I'll show you how. So this one is an example of what happens if you have a zero that's gonna be at the beginning of your answer. So if I look at this, can 7 go into 3? No, it can't. So I'm going to put a 0 up here at the top. 0 times 7 would be 0. Subtract, and I get 3. Then I bring down my 6. Can 7 go into 36? Yep, it goes in 5 times. 5 times 7 is 35. Subtract, and I get 1. Bring down my 5. 7 goes into 15. How many times? 2 times. 2 times 7 is 14. I'm going to subtract and get 1. So my answer here is 52, remainder 1. Now, I always suggest that people put this 0 here almost as a placeholder, because otherwise your numbers and your quotient will shift over, and sometimes that'll make you think you need to do an extra step. So I always put that 0 there as a placeholder. Now, there is a shortcut method, and if you're not comfortable with the shortcut method, this method is perfectly fine. But let me show you what we did back here, and multiplying 0 times 3 to get 0, and then subtracting, we get 3, bring down our 6. If you notice, we get the number 36 right here, right? So that number 30, these two problems are the same, but the difference is that we did not write out our multiplying by 0 step here. So we didn't skip it, but we knew that it was going to get us that 30 shortcut method. So can 7 go into 3? No, it goes in 0 times. Now, instead of doing 6 is the same as this number 36, right? So this is really just a shortcut. So can 7 go into 36? Yep, it goes in 5. Oops, wrong pencil. 5 times. 5 times 7 is 35. Subtract, and I get 1. Bring down my 5. 7 goes into 15 2 times. 2 times 7 is 14. Subtract, and I get 1. So my remainder is still 1. So if you notice, so we went right ahead and looked next door to that 6 to look at 36. Cut method, whoops. All right, let's talk about if our 0 happens in the middle. So 4 goes into 8 how many times? 2 times. 2 times 4 is 8. We're going to subtract and get 0. Bring down our 2. Okay, so we bring down our 2. Can 4 go into 2? No, it goes in 0 times. 0 times 4 is 0. Subtract, and I get 2. Bring down my 6. And now can 4 go into 26? Yep, it goes in 6 times. 6 times 4 is 24. Subtract, and I get 2. 206, remainder of 2. So that's what happens if you get it in the middle. 6 that we got back here. See how this 26 is right here? Now, there is a shortcut method, same kind of thing as we did with the other one. If you're not comfortable with it, you don't need to worry about this. I'm just showing you a different option. Okay, so can 4 go into 8? Yes, it goes in 2 times. 2 times 4 is 8. Subtract, and I get 0. Bring down my 2. Can 4 go into 2? Nope. So I'm going to put a 0 up here. Now, I could multiply 0 times 4 and get 0. I'm going to end up with 2. And then if I bring down this 6, it's going to get that same thing. So you could technically do that. If this doesn't make you comfortable, then don't do it. You're welcome to do the other way. Can 4 go into 26? Yes, it goes in 6 times. Oh, I changed my color. 6 times 4 is 24. Subtract, and I get 2. My remainder is 2. Okay, so if you notice, I get the same answer just with my shortcut. Okay, so let's try one more, and this time the 0 is going to be at the end of our quotient, and this one's really important, and this is the one where oftentimes people will forget the 0 and it impacts their answer. So we're going to do the same steps we did before. So can 6 go into 6? Yes, it goes in one time. 1 times 6 is 6. Subtract and I get 0. I'm going to bring down my 6. Can 6 go into 6? Yep, it goes in one time. 1 times 6 is 6. Subtract and I get 0. Bring down my 2. Can 6 go into 2? No, it can't. It goes in 0 times. Now, this is where it gets tricky. Sometimes people forget that 0, and instead of 110, they have 11, which is a completely different answer. So that 0 is very, very important. So 0 times 6 is 0. Subtract and I get 2. So I have a remainder of 2. So 110 remainder of 2. If you forget that 0, it says 11 remainder 2, which is a very, very different answer. So you just want to be really careful with being sure that that last 0 is in there. Otherwise, your answer changes. If you are out there doing long division and you're in need of a way to get your stuff lined up, your place values lined up, turning a piece of loose leaf paper sideways is a perfect way to get your stuff lined up. For example, if I have 4 as my divisor, and let's say I have 7,253 as my dividend. We don't need our line quite that long. Okay, so I would say in my head, just same thing, DMS down, dude. Oftentimes I will also write DMS down at the top to give myself a visual reminder. So can 4 go into 7? Yes, it goes in once. 1 times 4 is 4. Subtract and I get 3. See how I'm using these lines to help me line up? Bring down my 2. Can 4 go into 32? Yes, it goes in 8 times. 8 times 4 is 32. Subtract and I get 0. Bring down my 5. Can 4 go into 5? Yes, it goes in one time. 1 times 4 is 4. Subtract and I get 1. Bring down my 3. Can 4 go into 13? Yes, it goes in 3 times. 3 times 4 is 12. Subtract and I get 1. So my remainder is 1. So I hope this helps. By turning this paper sideways, it helps me really line up my work and make sure that my stuff is not kind of floating off to the side or not lined up. All right, thanks. Bye.